let's talk about something that we collectively call element, compound, and mixture. In order, a pure substance is basically 100% of whatever it may be. It may be pure sugar, pure salt, pure water, pure gold. It basically is 100% of something, therefore you can't really separate it, right? An element, on the other hand, is a certain type of atom, but that's somewhat misleading because we're not talking about necessarily, it could be a large chunk of something. For example, a brick of solid gold is an element. Yes, it's extraordinarily heavy. Yes, it's large, but it is an element because it is all of the same type of atom. You could have a 100% silver ring. That would be an element of silver. So an element, yes, this is the periodic table of the elements, but an element doesn't have to be one atom. It could be a collection of millions or billions or trillions of the same type of atom. So each of them have their own unique properties, both physical and chemical. We'll learn all about the elements later. They are amazing, and like I told you before, they make up the entire universe. So that's an element. A compound, on the other hand, is a collection of two or more elements bonded together in some fashion. Let me move this for you. As a compound, it has different properties than the individual elements. A compound is more complicated than the elements. A very simple example for you, which I find very fascinating, is, for example, hydrogen and oxygen. Hydrogen by itself is a gas. That's what brought down the Hindenburg blimp. Explosive gas. Oxygen is another combustible gas. It can be dangerous. We use it in our bodies because we combust it in a reaction called cellular respiration, which you guys learned about in biology. So these are two combustible gases. If you put them together in a 2-to-1 ratio, what you get, of course, is water, H2O. H2O is a liquid. Water's not a gas, or I guess it can be, but it's a liquid at room temperature, and it could put out, guess what? Fire. So water, which is H2O, can put out a fire created by combustible oxygen or hydrogen. Now, if you put it in a slightly different ratio of H2O2, two hydrogens for two oxygens, you get hydrogen peroxide, which is poisonous. So H2O2 is a liquid that will kill you. H2O, with the 2-to-1 ratio, is a liquid that we absolutely must have, and we cannot survive for more than a week without it. It is essential for life. Yet individually, you have hydrogen and oxygen, which are both combustible gases. That, in a nutshell, is what each have their own physical and chemical properties. When you combine them into a compound, their properties almost don't seem to matter. They take on a new form that is different, distinctly different, than the individual elements that make them up. That, again, I find fascinating, and that, like I said, basically is chemistry. So that's an element, a compound, and a mixture, which, again, are pure substances. A mixture, again, is basically two or more compounds or two or more elements put together. So we have two types. We have heterogeneous and homogeneous. Now, please don't confuse this with homozygous and heterozygous. That's biology. That's not what we're talking about. Homogeneous and heterogeneous. What this refers to is the consistency of the mixture. For example, if we have pure sand, like really fine beach sand, no shells, no rocks, that would be homogeneous because every grain within that mixture would be basically the same. Might have slightly different colors, slightly different textures or shapes, but fundamentally it's still sand. If I was to take a mixture, potting soil has all sorts of different stuff, the rich soil, it has, sometimes little pieces of bark, it has sometimes even a little bit of styrofoam. It has a whole bunch of stuff thrown in there. That is a heterogeneous mixture. The consistency is very different. It can be chunky, for lack of better terms. Those are both mixtures, but they are very, very different. Homogeneous is very, very consistent throughout. I could take a handful of beach sand over here, handful of beach sand over there, as long as it's from the same beach, and it's filtered. It should be pretty much the same thing. If I take a handful of potting soil, it's going to be completely different as to what is in my hands. So that's the difference between those two different types of mixtures, heterogeneous and homogeneous. An alloy, you may have heard of it. An alloy is a mixture of different metals. Now, metals, when you put them together, do not actually bond. What happens is you melt them, or you smelt them, and then you mix them when they're in the liquid state, and then they cool to take on new properties. Some examples here would be like pewter. If you ever heard of pewter jewelry, it's very soft. It's made of aluminum and tin, not a very hard metal at all. Another alloy would be brass. Brass is not an element. Brass is an alloy made of copper and something. Those are alloys. Those, again, are their own different things. They're just mixtures of metals which have slightly different properties. For example, we use alloys for our wheels on our cars because we could mix metals that are strong yet light. So we don't have a heavy wheel on our cars, which is very hard to get moving and has a lot of inertia. That's not safe. But we also don't want it soft, that we hit a speed bump or a curb, and we just completely dent the thing out of alignment. So our alloy wheels are mixed of a very strong and a very light metal. Put together, it gives us a very nice, different type of metal. All right, guys, I'm going to stop there again, trying to keep these nice and short. That is all about elements, compounds, and mixtures.